Okay, thanks for tuning back in. We're going to do one more Euler's method. I'm actually going to do two examples, but in this video, just one more, where we actually are going to work backwards. So this is where we are in the notes. So if you want to find that, this is just right underneath the notes we just took. The first thing I do want to just say real quickly, and this holds true in other linear approximation problems, is if a graph is concave up, the linear approximation would be an underestimate. And then if the graph is concave down, our linear approximation would be an overestimate. So that's just something to keep in mind. You might be asked about that, but you could just draw a picture to determine that. You might have to calculate the second derivative, but we'll practice that at another time. Okay, so let's practice another Euler's problem. So we're given the derivative right here, 2x minus y, and we're given an initial value of 2, 3. I'm going to change the problem a little bit because this is a little bit long. So we're actually just going to do 2 equal steps to approximate 1.5. So let's chart our path here. So we're starting at the point 2, 3. We're going to take 2 steps, and we're going to approximate 1.5. So the value in between that is going to be 1.25. Okay? All right. So I'm going to start by writing an equation of the tangent line. So I need the slope and a point. So my slope is going to equal 2 times x, which is 2, minus y, which is 3. So my slope is equal to 1. The equation of my tangent line is going to be 1 times x minus 2 plus 3. Okay, so I just took what I knew, my slope, and I took the point, and I wrote a tangent line. I'm going to use this tangent line equation to approximate that y value. So I'm going to put in x. Y is equal to 1 times 1.25. Oh, that should be 1.75. Whoops, let me fix that. Oh, that was a good catch on my part. Did you guys catch that? 1.75 minus 2 plus 3. So this is going to equal a negative 0.25 plus 3, which would equal 2.75. If you're a little wobbly with decimals like I am, you might just double check it. I'm just double checking. And yep, 2.75, I was right. So that's my new approximation at my halfway point. So I use that equation to approximate this value. Okay, now I'm going to write a new tangent line equation using this new value. So maybe I'll switch colors so it stands out. So m is equal to 2x minus y. I'm going to use my new point. 2 times x, which is 1.75, minus 2.75. And I'm calculating that. Okay, and then I get 0.75 on that. So now I'm going to write with my new point and my new slope the new tangent line. So my slope is 0.75 times x minus 1.75 plus 2.75. Okay, so that's my new equation and my new line. And I'm going to use this. I'm going to pick yellow. Well, maybe I'll do pink. I'm going to use this new line right here to approximate that value. Okay? So with that, I'm going to do y is equal to 0.75 times 1.5 minus 1.75 plus 2.75. So I'm multiplying that with my calculator. Whoops, I messed up. 0.75 times negative 0.25 plus 2.75. And on that, I got y is equal to 2.5625. I'm just going to cut that off at 3 decimal places because that's what we normally do. I'm going to go back and do green here. 2.562. Okay? So f of 1.5 is approximately 2.562. And that's a way to approximate a value using Euler's. Okay, we'll do one more example in another video, but I really appreciate you watching. Thank you.